So this question here, which statement is false? It was number 33 on the test about interfaces. Number one, all methods are public. Interfaces cannot be instantiated. Interface can declare an instance variable. Non-abstract methods, non-abstract classes can implement the interface, and abstract classes can implement the interface. So which statement is false? All methods are public. That's true. If all methods weren't public, then the class that's implementing the interface wouldn't be able to access, and override the method definition, right? So this is true. And interfaces cannot be instantiated. That is true, right? An interface cannot be instantiated, meaning you cannot make an instance of an interface, right? We have like interface, like dog, and dog has a set of abstract methods in its definition. You cannot instantiate dog, right? But if you have, Chihuahua that implements the dog interface and defines all of the abstract methods, then Chihuahua can be instantiated, right? But not dog, not the interface, right? Can't be instantiated. So yeah, what I said in front of you guys was actually true, right? And then interface can declare an instance variable. So this is false, right? So like I said that interfaces can declare an instance variable, but that instance variable has to be public, static, and final, right? So that was wrong. And when I looked it up online, like I just typed this in on Google, and it took me to a web page that said that the instance, like the variable that you declare in an interface, is not an instance variable. It is a class variable, right? And I was like, oh, how cheesy. That was my first response, right? Like, okay, it's a semantic error. Like, okay, they call them class variables. They don't call them instance variables, but they are instance variables. That was my first reaction, but that was wrong, because interfaces, like this all makes sense because interfaces cannot be instantiated, right? So any variable that's declared in an interface must be static, final, public, static, and final. And so if it's static and final, that means that it can't be changed, and it's also available to all the objects that implement the interface, right? All the classes that implement the interface, and all the objects that implement the interface. So what was my point? Oh, my point is that you can't have an instance of the interface. So if you can't have an instance, then how can you have an instance variable? Because if you do have an instance variable defined in the interface, that means for an instance of the interface, you will have a variable that is, like special to that one instance, right? So if I have 5 instances of this interface, then that instance variable would be recreated in each of those different instances, in each of those objects of the interface. So that doesn't make sense because you can't have an instance of the interface. So you can't have an instance variable, right? So yeah, that makes sense to me. And then it's called a class variable, right? For good reason, because it belongs to the class. So if we have the dog interface, right, and we have this static final variable, it'd be like dog dot, and then it'd be this like age or something like that, or maybe like total dogs, right? So then you would name the interface, and then you would say the class variable's name, right? So that's how you would access it. So you would access it via the interface name, not via an object of type interface. Okay, and then the last two are non-abstracts can implement an interface. That's true, right? If it's like a concrete class, it can implement an interface. That's like obviously true. And then abstract classes can implement an interface. Yes, that's true. But that whole that child class, you cannot you cannot create an instance of the child class because it is abstract, right? It's not until you have a subclass that defines all of those abstract methods that are in the class, along with the abstract methods that are defined in interface, that you can create an object of that class, right? So yeah, that's kind of what I uncovered here.